Hello everyone, welcome to my YouTube channel where I like to talk about game development. I hope you are doing well and everything is going well too. Today, we continue with the second part of the series. In this part, I'm gonna cover creating navigation system, adding different type of navigation areas, adding player and enemy models to the scene, adding components to the models, creating model controller and implement to the player and enemy models. So let's get started if you are ready. To be able to create navigation system, we're gonna need some additional components, which you can download from the GitHub. Navmesh components is gonna give us the Navmesh surface component, which we're gonna use to back navigation areas. To keep everything organized, we are creating a parent game object with the name navigation. Then we are adding sub-game object with the name Navmesh and adding Navmesh surface component to it. There are some settings on the component which you can check and change, but for now we are focusing on the include layer sections. This section is going to be used for backing. So we need a new layer which we're going to use for backing navigation areas. We are adding a new layer as walkable. The name here is not important. You can choose a different name as you wish, but I prefer to go with the walkable. After we have added the walkable layer, we are turning back to Navmesh surface component and choosing this layer as the include layers. So the backing will include the only objects with the walkable layer. Now we need to add some planes to the scene. We are adding planes according to navigation areas where we want to have, and we are changing their layer to the walkable layer. Also, we need to add a box collider for each plane which we want to use for navigation. This collider is going to help us with the both click to move function and playing different foot sound effects according to type of the area such as grass and wood. Then we click back on the Navmesh surface component to back navigation areas. As you can see, there are blue areas on the scene. This color represents the navigation areas where the models can walk. But we don't want to show these areas in the game. That's why we need to change the cooling mask option of the camera. By extracting this layer from the list, we are simply telling to the camera to not display this layer. We continue to add planes wherever we want to have navigational areas. And when we finish, we click the back on the Navmesh surface component. So now we have completed navigational area in the scene. Let's focus on the type of the area now. As I mentioned, we're gonna play different sound effects according to type of the navigation area. To be able to do this, we need a new component. So let's create a script as a grunt type and another script as definitions, which we're gonna use for different purposes. We are deleting the start and update methods because we are not going to use them. Let's start with the definitions. We have two different types such as grass and wood. Let's define them here. As we have completed the definitions, let's continue with the grunt type. We're going to use this class to change the type of the navigation area. Because of that, we need a property to set grunt type. We are defining this as a grunt type. And then we need to access this property from out of the class. That's why we are defining a public method which is going to return the type of the grunt which we choose. So we have finished coding. For now, let's turn back to the Unity and then add this script to all planes which we added before as navigation area. After that, we can choose the grunt type as we wish for each plane of the navigational area. Maybe it doesn't make sense for now, but we're gonna see in the upcoming parts how to use this script to play different sound effects. For the footstep sound effects, I'm gonna use free assets which you can download from the asset store for free and use it in your game. So, we have just finished adding navigation system. We're gonna continue with adding models to the scene. We are starting with the player. We are creating an empty game object and name it as a player. Then we are adding our model into this parent game object. Please keep in mind that we're gonna add all the components to the parent game object. We're gonna need an animator component. So let's start by adding it. This component is gonna help us with the playing animation for the models. We can copy the animator controller from the model and paste it to the parent game object. And then we can delete the component from the model. We continue by adding Capsule Collider. We are adding the component and arranging it according to our model. The next one is the rigid body. We are adding the rigid body component to our parent game object and enabling the kinetic option of the component. So we already have 3 components on our parent game object. We want our models to move. So now we're gonna add related components for this purpose. We are adding NavMesh agent. This component is gonna drive our models for navigation. We are arranging the component according to our model. So the last but not least, we are adding audio source component. We're gonna use this component for playing some sound effects. As final for now, we're gonna create and add model controller. But before that, let's add same components for the enemy model. As we have both player and enemy models in the scene with their components, now we can continue with the model controller component. We are creating a script and name it as model controller. For now, if you are ready, let's start coding this component. We are starting by defining movement settings for the models. The models are gonna use those settings for movement. We are defining initial values, but those are not the final values. We're gonna change them according to our models. Then we continue with foot IQ variable, which we're gonna assign the ground layer on it later on. So the models are gonna be able to understand if they are contacting to the ground or not. Next, we are defining variables for sound effects. We are defining list variables with the audio clip type. We're gonna use those variables to assign the sound effects which we wanna use as a foot sounds. Till here, we have defined the variables which we are gonna be able to update via Unity editor. Now let's define the variables which are gonna be private and not updatable via the editor. We are defining movement type, but most probably, as you already noticed, we don't have such type which we have defined before. So let's open the definition file again and define movement type enum as walk and run. Then we continue with ground type, NavMesh agent, animator, and audio source. Those are the components that we already added to our model. We're gonna access and use them via script. we are defining some weight variables to be able to control foot IK. Those variables are going to help us to put and rotate feet correctly according to ground. As last, we are defining a variable as an offset for foot, which we're going to use to close the gap between the models and the ground. We need to assign components to the variables that we have defined above. We are doing this in the start method. We are accessing the animator, Navigational agent, and audio source component here. We don't want the animation to drive the model. That's why we are setting the animator's update motion property to false. Also, we're gonna move our model from the script. That's why we are disabling the update position and rotation properties of the Navigational agent to avoid additional movement and rotation. As we have defined the variables which we need, we can continue with the update method. We are starting by checking ground. We're gonna add some empty methods, which we're gonna fill them later. We are defining the volt delta position variable to hold the distance between the agent's next position and the current position. We're gonna use it to understand if the model is moving in the x-z direction. We continue with isMoving variable, which we're gonna use to understand if the model is moving or not. If you pay attention, we are using sensitivity variable here, which we have defined before. We are using it to avoid very small movements on the model. We don't want to count such small values as a movement. Finally, we are calling update animation and apply extra turn rotation methods, which we're gonna define soon. Now, let's write the fixed update method, which we're gonna use to update the transform position. To be able to arrange foot IK, we need to communicate with the animator. We're gonna do it in the onAnimator IK method. We are defining arrange foot IK method, which we're gonna fill in now. Okay, let's start with arrange foot IK method. We are checking if the foot IK is enabled. If it is, we are getting the right foot's IK position. And then we are raycasting from the foot to the ground to detect hit position of right foot. And we are setting the related variables of weight which we have defined before. The values of those variables are 1. We are using them here because we want to activate the foot IK. That's why we are setting their values as 1. Then we continue with rotation of the right foot. If the weight is greater than 1, we are rotating the right foot accordingly. Actually, we don't really need to check if it is greater than 1, since we set the value and never touched again. We can delete this if statement and update right foot's rotation directly. Or you can leave it as it is, to have a chance to disable it, just making the value of related variable 0. Then with the else, we are setting both position and rotation for right foot IK weight as 0, if we cannot detect the ground. We continue by repeating the same steps for the left foot. At the end, we are setting all weights as 0 if foot IK is not enabled. As we have finished arranged foot IK, we can continue with update animation method. Here, we are checking if the use speed is enabled or not. If it is, we are setting the value of the speed in the animator according to the parameter of the method. We have defined this variable for the animation controller in the previous video. Then we are setting the move variable of the animator from the parameter of the method. The next method is update position transform. Here we are setting transform position. As you can see, there is a fixed value here which is 0.9. I don't know why exact this value should be, but this is the value which is writing in the documentation of the Unity. And if you want to get good result, don't touch it. Or maybe you can test and find better way. It's up to you guys. In the apply extra turn rotation method, we are transforming the move direction from world space to local space. Then we project a vector by using ground normal. Next, we are calculating turn amount by using x and z values of the move direction. Then by using the lerp function, we are calculating the turn speed and rotating the transform. We continue with check ground method. In this method, we are overlapping the ground layer and trying to reach colliders that we have added before in the navigation part. And if we found any, we are getting the ground type component from it and setting it to the private variable which we have defined. We didn't add ground type component to the navigation playlist. We're gonna add them later. After mentioning this, we are defining the step method. This is the method which we're gonna play foot sound effects. If you remember, in the previous video we have talked about animation events. So this is the name of the method which we have defined before as an event in both walking and running animations. What we are doing here is pretty straightforward. We are playing sound effects if there are any. But while playing the foot sound effect, we don't want to continue to play same every time. It is very unrealistic. That's why we are defining a method which is getRandomWalk. This method is getting randomly sound effects according to active ground type. If you remember, we have already written code to detect the ground type and set it to the private variable. So this is the where we are using it. We are getting detected ground type by using getActiveGroundType method. This method returns active detected ground type as a response. The next method is the model reached. In this method, we are checking if the model reaches to the final target by checking some of the values of the navmesh agent. Then we are defining start move animation. This method simply sets the move and speed variable of the animation controller just before the model starts to move. We are doing this because when model starts moving, there is a little gap between the animation and the model. To close this gap, we are first setting animation variables just before the model starts moving. So we have completed big part of the model controller. Additional few methods left. We need to define an eye animator to set the bunch of properties of the navmesh agent. So let's continue with that. In this method, there is a navigation type enum. It is the same as the other two enums which we have in the definition file. You can define and use it. There are two values for this enum, such as calculated and set destination. The reason why we have these options here, to be honest, for this tutorial, it is not gonna make any difference. But I want to share with you guys as additional information. When you are setting navmesh agent destination directly by using destination, there are some performance issues with that. When there are too many models in your scene, and when you set the destination for each of them in this way, you're gonna see a dramatic performance drop in your game. On the other hand, when you set destination by using the setPath function, you are not gonna have any performance issues. Just a little information to share. So, in this method, we are setting the destination according to navigation type. And then we start move animation and set the speed of the agent according to active movement type, which could be walk or run. Then we continue to define the same method with different parameter types. The first method expects raycast hit as a target position, but the second method expects vector 3 as a position. The reason why we have two methods here is, in the coming videos, we're gonna set up click to move structure. For that, we're gonna use raycast hit. At the same time, enemies need vector 3 as a player location. Because of that, we have same methods only with one difference of parameter. But we can make these methods more simple by refactoring them. Let's move now mesh path calculation to the new method, which is the getCalculatedPath. Then let's move model speed assigning to the new method, which is the setModelSpeed. After refactoring, let's add the public methods, which are gonna call these methods from out of the script. And finally, let's add a method to stop our agent. So now we can turn back to Unity Editor and add the model controller script to both player and enemy models. We can set the values for the model controller and add food sounds effects. Then we need some additional arrangement for grant types. If you remember, in the model controller script, we are checking grant type by looking the tag field. Because of that, we need to add new tag, and then select this tag for all navigational areas which we have added to our scene. And one more last thing. We're gonna use layers in the next videos. So let's create two new layers, such as player and enemy, and set them for models. In this part, we have created navigation system with the support of the different types of the grounds. We have added our models and their components. Finally, we have created model controller script and attached it to the models. In the next part, we're gonna see how to implement the click to move structure into our game. Things gonna be more interesting and interactive. Guys, I really appreciate that you gave your time and watched this video. I hope you learned something new. If there are some suggestions to make these videos better, please share them with me in the comment section and help me to grow this channel. So don't forget to like the video and please consider subscribing. Thanks again. See you.